Okay, and I will share my screen. First of all, I want to explain about the project instruction which have been given in the author. Okay, which has been given in the author. So everybody can see my screen, you can hear my voice. Boleh dengar
Boleh Dr. boleh.
Okay, thank you. Okay, so if you open your author system, look into the learning materials, okay, and go to the PBL Assignment 1, okay. So you can download this doc file, okay, the Microsoft doc file, and then you can read and read and try to understand the given instructions, okay. And another thing is that please browse through the course info so that you can see all the given all the given information here regarding the recorded lecture video, the date for the test and quiz, okay. And I hope that you can check again about the given date. Is this date suitable for you or not? If this date is not suitable because you have other assessment or test quiz from other subject, please inform me earlier, okay. Please inform me earlier, okay. So and then let's look in the PBL project assignment 1, okay. PBL assignment 1, which is this document, okay, this document. So this is a PBL assignment, problem-based learning assignment. You will be given two topics, two assignments, two tasks. Okay, the first task is about noise. The second task will be given later. Okay, the second task will be given later about digital modulation and transmission. Okay. So this is BEJ for BEJ students, semester 2, course code BEJ 30103, communication system, electronic communication systems. And the learning outcome for this subject is analyze various types of electrical noise and digital modulation techniques in communication system, practice professionalism in teamwork to solve the given problem. Okay. Construct report and recorded presentation videos related to the given PBL instructions. Okay. So remember, this is teamwork. Okay. So make sure that all group members give full commitment to complete this task. Okay. So if let's say there's a group member that don't want to collaborate, don't want to give commitment in the given task, what you can do is that you can discuss with other group members, conduct a meeting, and then you can kick this person out from your group. Okay, you can remove this person out from your group if this person does not give any commitment to the given task. Okay, what you can do is conduct a meeting with other group members and remove this person. You need to inform me earlier if this happened to your group. Okay, so I repeat again in Malay. So kalau ada group member yang tidak memberikan kerjasama, kamu boleh buang dia daripada group. But in order to do that, you need to conduct group meeting, record it in the minute meetings, and inform me earlier. Okay, I will ask this person to do the project by himself or herself. Okay, so make sure everybody collaborate and give full commitment. Okay, so the task duration for first task 5 weeks, 10%, task 2 around 6 weeks, and the marks will be given 10% also. So the total mark for this project is 20% of your coursework marks. Okay, and the submission date for task 1, which is on 21st of May 2022, this is on Saturday. Okay, this is on Saturday. And task 2 expected submission date is 5th of July, which is during the study week. Okay, so this is group work. Okay, so I will explain about the instruction. Okay, so if you have question regarding the given task, please ask question now. Okay, boleh tanya sekarang. You can ask me about the things that have been shown here if you don't understand. Okay, hopefully you can have better understanding when I'm explaining about this instruction. Okay, so this is a PBL assignment. So PBL is a problem-based learning, which is a student-centered approach in which students learn about subject by working in groups to solve an open-ended problem. So you will be given open-ended problem. There is no one solution to the given problem. There are many solutions. So you need to suggest one of the best solution for the given problem. Okay. So this problem is what derive the motivation and learning process. Okay. So PBL is related to Nielsen, which lists the following learning outcomes that are associated with PBL. So a well-designed PBL project provides students with the opportunity to develop skills related to working in team, okay, self-awareness and evaluation of group processes, self-directed learning, critical thinking and analysis, research and information literacy, oral and written communication, applying course content to real-world examples, and problem solving across disciplines. So we hope that you can develop these skills during the given project duration. Okay. So the guidelines to student, each group consists of 5 to 6 persons only. Combination of male and female student is highly recommended. The ideal ratio is 1:1. If possible, the higher degree of diversity, gender, race is most welcome. Okay. Choose your group member and group number in author via group activities tab. So I believe you already done this. The group member and identification group should remain in all PBL activities throughout the semester. So you will remain in the same group for the second task later. So due date for the finalized group designation, which is last week. So I hope that you already find a group and already have a WhatsApp group with your team member. Okay. Lecturer can make adjustment, amendment on your group's designation if needed, especially in the case of groups designation do not follow the guideline. So once finalized, fill in the group form for the record. So the group form will be given in this document. I will show you later. Okay. So PBL activities, there are 2 PBL activities are planned throughout this semester, which is related to chapter 2, noise. Okay. So this is the first task. The second task is about chapter 4 for digital communication. So please refer to the PBL design sheet or for more details later. Okay, so today I give you only this instruction for task 1. Later I will give you task 2. Okay. So the timeline for executing these activities is approximately 4 weeks from the start date. So I believe that you can do within 4 weeks is enough actually. But I give more than 4 weeks, around 5 weeks from now. Okay. So activities are done by grouping throughout the discussion and tasks. You should arrange and organize your tasks within group. The output of PBL activities are observed by report, okay, and video presentation. Okay, so there are 2 outputs that need to be submitted. The first one is the group report. The second one is the recorded video presentation. Okay, group report, the format I will give you later about the format, but for now there's no specific format. There's no specific format. Okay, actually, but if you need a format, I will give the format later. What is the requirement in the report, I will show you later. Okay, and then video presentation, it is about recorded video for about 20 to 30 minutes. Okay, and each group member must speak during the presentation. Okay, So PBL report and presentation video must be submitted through author before the due date. Okay. So since the video file is large, so I recommend you to upload in the YouTube. Okay. So you upload the video in the YouTube and you give the YouTube link in your PBL report. Okay. At the end of the report, you give the YouTube link so that I can see the video presentation. So you don't need to upload video in the author, okay, because author only allowed up to 500 megabytes only. Okay, and then this is the PBL group form. So you need to fill in your information, your name, matrix number and phone number, and also your photo here, okay, and also the group number here. Okay, so maximum is 6 students. So most group have 5 members. Only one group has 6 person. Okay. So this group member you need to fill in and submit together with the project report later. Okay. This group form need to be included in the project report. So what is the instruction? This is the instruction. Okay. Topic noise, chapter 2. Okay, this is 10%. So the first PBL activity requires depth knowledge of electrical noise, chapter 2, to solve the complex problem of noise impairment in the communication system. So this is related to complex problem attribute number 1 mapped to the course learning outcome number 1. So we have learned about noise last week. Okay, so you can do self-study using the given recorded video in the YouTube. Okay, in the lecture video last week, you can learn more about the noise. Students are given a range of technical specifications and limitation for the amplifiers and chambers in the analog receiver system. So this is a complex problem attribute number 2. So you will see later, okay, later you will see that you are given specific instructions, specification of amplifiers, which you need to calculate the noise. Okay, so students need to analyze the resulting signal to noise ratio, SNR characteristic, and propose a solution to reduce the noise impairment in the system. So this is related to complex problem attribute number 3. Okay, so remember what we have learned last week, that we need to achieve the highest we need to achieve SNR as high as possible. Okay, ideally we want SNR to be as high as possible, and in order to do that, we need to reduce the noise as low as possible. Okay, so one of the method is to reduce the noise impairment in the system. Okay, how to do that, you will see later. Students need to form small group members, each with a member allocate 5 maximum or 6 or 5 or 6 students, with each member allocated individual responsibilities or portfolios to complete the given task within specific timeline. Okay, so you need to discuss with your group member what are the tasks for each group member, so that everybody understand and can commit to complete the project activities. Okay, so no budget is allocated for the PBL project, no specific labs or workshop are scheduled. Groups must manage and schedule their own resource requirements. So this is engineering activity attribute number 1 mapped to the course learning outcome number 2. Okay, this PBL activity involve group discussion on the wide ranging of technical requirements to resolve the noise impairment problems by proposing the best solution, okay, with the highest SNR level. At the end of this PBL activity, each group of students needs to submit a technical report and a recorded video presentation of the proposed problem solution. and this is related to engineering activities attribute number 2 and course learning outcome number 3. Okay, so you will see the given system later. Okay, so since this is a PBL, so problem based learning, so that means we need the trigger statement. What is the trigger problem? Okay, so communication engineers always strive to maximize SNR. Okay, traditionally this has been done by using the narrowest possible receiving system bandwidth consistent with the data speed desired. However, there are other methods. For example, engineers might use spread spectrum technique to improve system performance, or they might boost the signal output power to increase the SNR. In some high-level systems such as radio telescopes, internal noise is minimized by lowering the temperature of the receiving circuitry to near absolute zero, or minus 273 degrees Celsius or minus 459 degrees Fahrenheit. In wireless system, it is always important to optimize the performance of the transmitting and receiving antennas in order to achieve the highest possible SNR. So you can look into this website. This is just example of website regarding signal to noise ratio. There are many other websites that explain in details about signal to noise ratio. Okay, it doesn't mean that you need to depend on this website only. You can also search in other websites. Okay, so if you ask me, the first task does not require you to use any specific software. Okay, the first task does not require you to use specific software. Even if you don't use any software, is also okay. Okay, but if you want to use software, any software, to help you to find the best solution, you are most welcome. Okay, so the problem, this one. Okay, problem statement and instruction. So based on figure 1 below, propose a solution to produce the highest signal to noise ratio SNR output of the communication system from consistently 6 watt received signal and bandwidth of 500 megahertz. So that means you are receiving 6 watt of input signal from the antenna, and the signal has a bandwidth of 500 megahertz. Okay, and you see that here the temperature, this is the picture of sun, so the temperature is 35 degrees Celsius. So you know how to do this. That means you need to convert into Kelvin so that you can do the calculation. Okay, so you are given 3 cascaded amplifiers. So each amplifier is put in a chamber. Okay, so they're gonna be amplifier specification and also chambers specifications. Okay, so you are given this specification for the amplifiers. Okay, so all amplifier devices are portable. Okay, portable means you can take out the amplifier. Okay, you can take out the amplifier. You can do the arrangement in order to find the best SNR. Okay, so each amplifier has a specific gain 8 dB, 40 and 10 dB. Okay, and the chambers are non-portable. That means you cannot take out the chambers. The chamber is static in the place. Okay, so the chamber is given initial temperature 350, chamber 1 for example 350 Kelvin, and this chamber can regulate the temperature between 25 degrees Celsius until 350 Kelvin. So initially it is the highest temperature. Chamber number 2, 87 Celsius, and this is a non-controlled temperature. So chamber number 2 cannot control the temperature. chamber number 3, 450 Kelvin initial temperature, and it can regulate the temperature between 22 Celsius until 450 Kelvin. Okay, so amplifiers are portable, chambers are non-portable. Okay, so the first instruction, you can propose any practical solution based on the following conditions and limitations. You can propose practical solutions based on the following condition and limitation to increase the output SNR. So SNR is measured at the output. Okay, so based on this setting, based on this specification and limitation, how can we improve the output SNR? How to do that? Okay, one of the thing is that you can rearrange the amplifiers, or maybe you want also you want to control the temperature, for example, you can do that. Okay, but for the first question, this one, you are not allowed to add additional component into the system. Just as it is, you just need to use whatever it is right now from the original arrangement, and then you come out with new solution to increase the SNR. Okay, so if you have question, please ask. Okay, I will try to give more explanation about this. So this is the first question. The second question, if you see here, without considering the mentioned condition and limitation, without considering the mentioned condition and limitation, what could you propose to further enhance the output SNR? Discuss and elaborate. Okay, remember, discuss and elaborate. So when you get the best SNR in question number 1, okay, when you already propose the best SNR for question number 1, then you move to question number 2. How to further enhance the SNR? You can suggest anything into the given system. Okay, in question number 2, you can suggest anything to the given arrangement, to the given system. For example, you want to add more components. Okay, for example, like filtering process and others, so that you can further improve the SNR. You can do that. Okay, but my suggestion, okay, remember, this is discuss and elaborate. That means you need to show that by doing this suggestion, you can improve SNR for how much. Okay, the best is you can give further calculation. That's the best. Okay, for example, if I suggest solution using method A, for example, this method A, I do for example, I make some arrangement, I include some additional components to reduce the noise, for example, and I make a simple calculation. Okay, make a simple calculation just to show that with this kind of solution, I can further increase the SNR for about approximately, for example, 10 dB, for example. Okay, don't just write a few sentences to describe. Okay, you need also to elaborate. If you have picture, put pictures. Better. Okay, if you can, the best is to show the calculations. Okay, for how much it can be improved, show it, prove it. Okay, so PBL activities, discuss and summarize the FILA table. So FILA table is the the preparation, the beginning planning is the planning phase. Don't do FILA table at the end of your project. FILA table is for the planning process. Okay, you need to include a few steps, as many as possible steps in the filler table to complete from beginning until the end. Okay, and then prepare the brainstorming process by providing the appropriate tools such as fishbone diagram or flowchart or mind chart or any other charts suitable to show the brainstorming process with among your group members. Okay, and then prepare the report and video presentation. So maximum duration is around 20 minutes. So if you need until 30 minutes is also okay, but no need too long. Okay, 20 minutes is just nice. Okay, to describe your work. Submit via author before 21st of May 2022. Okay, so for the first task, there are 2 questions that you need to do. Okay, it will take short time to complete this. Okay, the sooner, if you can complete before 21st of May, you are most welcome to submit. You don't need to wait until 21st of May. Tak perlu tunggu sampai 21st of May. If you have complete, you can submit. And then I will give you the second task. Okay. So video, as I mentioned before, video presentation, recorded video, upload in the YouTube and share the link to me. Okay. And then what? Self-reflection. Okay, self-reflection form. So this is the complex engineering problem identification form, which is the self-reflection. So this is a group. Okay, this is group self-reflection, not individual. Okay, this is group self-reflection, not individual. Okay, so this self-reflection need to be included in the report. Okay, in the report you include one self-reflection. Okay, so the self-reflection, very simple. This is I asked you 3 questions only. What is the new knowledge you have learned from this assignment? So you can just give a brief description over here. Briefly describe about the given question. Okay, and then in your opinion, what is the most complex issue in completing the given task? So you can explain here. Okay, how did your group comes up with the idea of the best possible solution to the given complex problem? So you can give your answer here. Okay, so if you need more space, you can go to second page. Okay, ideally only 1 page. If you need to describe a lot, you can go to the second page. Okay, so no need to strict your limit, only 1 page of self-reflection. Okay, ideally only 1 page is needed, but if you need more, you can do more, no problem. Okay, so that's all for the first task instruction. Any question you want to ask? Ada soalan tak nak tanya? Please ask question. Anything? Is there anything you don't understand about this instruction? Boleh tanya. If you don't understand, please ask. Otherwise, I assume that you understand. Student, are you still there? Semua masih ada di sana?
Ada.
Okay. So maybe you don't have question now, maybe. Okay. But if you have question now, please ask. Okay. If you want to ask later, also okay, no problem. Tak ada masalah. Okay. If you want to ask question, I prefer you to ask question in the WhatsApp group, so that if your friends can help you to answer the question, your friend will answer. Otherwise, I will answer your question, no problem. Okay. So this task, the first task of this project, is more about calculations and also literature survey. Okay, about how to improve the SNR. Okay, You are not required to use any software to complete the task. However, if you want to use any software that you like to further explain your proposed solution, you are most welcome. Okay. For example, you want to use MATLAB to further explain about your proposed solution. You are most welcome. Okay, you are most welcome. Of course, siapa yang guna, if you use if you use extra things, for example, if you use additional software to further explain your explanations, your solutions, and other groups don't use any software, you will get more marks than the other group. Okay, I will give bonus marks for those who use extra. For example, you use additional software to explain, of course. Okay, so whoever give the best report, the best video presentation will get the highest marks. And I will also give the rubric marks, the rubric assessment. So from there you will know what are the criteria that will be assessed in this first task. Okay. So any question? Ada soalan tak? Senyap je. Belum ada soalan Apa dia? Belum lagi? No question yet?
Doktor nak tanya, attendance dah ambil ke?
Attendance bila?
Attendance hari ni.
Oh belum, attendance hari ni nanti akhir kelas. Kenapa ya? You nak attend?
Oh,
You
saya
nak
check
keluar
kat
dulu, nak keluar awal ke?
Smart. Tak, saya check kat Smart dia telah absent.
Bila? Hari ni? Oh belum
Kan dah
lagi.
ambil tadi.
Belum. Attendance will be given at the end of the class. Maybe between 4:30 to 5 PM. Boleh
Boleh tak?
Okay. Any question about this project? Ada soalan? Everybody understand? If you understand, that's very good. Okay. So for your information, previously, before the pandemic, before the COVID pandemic, I give students a project about designing the hardware for transmitter and receiver, where you need to create your own transmitter and receiver that has the capability to transmit signal. Okay, but because of this pandemic, I know that some of you are not around here, still in the hometown, so that kind of project is not suitable. So maybe after the pandemic, maybe next semester, maybe I will give the hardware projects for the students. Okay, it's more interesting, maybe. Okay. So if you don't have question, I will begin with my lecture session, which is about chapter 3. Okay, chapter 3. So about this one, later I will put for the submission. Submission will be given in the group activities. Okay, in the group activities later I will put submission of a report and video presentation in the group activities. Okay, so you can put in the group activities, and please make sure that you commit. Okay, make sure you commit and you give your full commitment. Okay, you collaborate with your friends to complete the given task. Okay, and I hope that you give this one, especially this part too, you need to elaborate more. Okay, don't just write a few sentences. No. Okay, you need to explain, give the best explanation. Okay, My suggestion, don't do this task last minute. Okay, I know whoever do the project last minute, of course there will be distinct difference between the group that do from the beginning and the group that do last minute. Okay, there will be distinct differences in the report. Okay, akan nampak perbezaan yang ketara dalam report antara group yang buat daripada awal dengan group yang buat last minute. Okay, and remember, don't copy and paste report from other groups. Okay, so don't copy and paste from other groups. Okay, so I expect, since we have 5, so we have 20 something, so we have 6 group, I think. So I believe that we should have at least 6 proposed methods at least, and I believe that each group will have their own unique solution. Okay, don't copy and paste from other group. Okay, so be careful about that. Okay, so since there's no question until now regarding this project, I believe you understand, or maybe you don't have any question yet. You can ask later, and make sure you can straight away discuss with your group members starting from today. Okay, so that you can finish earlier. Okay, so let's start with chapter 3. Okay, chapter 3. Okay, so this class, as usual, relax. Okay, don't feel stressed. Jangan stress. Relax. If you have questions, please ask question. Okay, feel free to interrupt me anytime during the lecture session. Okay, boleh tanya pada bila-bila masa. Okay, again, as usual, if you feel tired, you can go somewhere else, and then you can come back to the class. Okay, make sure you are here in this class between 4:30 to 5 p.m. because I will take the attendance. Okay. Okay, so before I begin, can I get your response? Are you still there? Can you hear my voice? Can you see my screen?
Yes, doctor.
Okay, thank you for the response. Okay, because now I cannot see your face, because I can see my screen only. Okay, so now, as last week we have learned about chapter 2, which is about the noise, and we learn mostly about the thermal noise, the noise that is related to the temperature variation. Okay, you have learned that the noise exists in the system, in the transmitter and receiver, and also exists in the medium or channel. Okay, now we want to see the process happens inside the transmitter and receiver, and the process that we want to learn is more focused on the modulation process. Okay, modulation process. And what kind of modulation process that we want to learn? This is related to analog modulation. So if you remember about analog, I already explained previously in chapter 1. So this analog modulation, this is related to the process happens in the analog system. Okay, so we have an analog system of transmitter and receiver, for example. Okay, and this is the channel. Okay, and then we have the receiver. Okay, transmitter and receiver. Okay, so for analog system, that means the input is analog. Okay, the input is analog, and the system do the process in analog and transmit as analog. It can be transmitted as wired, but in this lecture session, you will learn about wireless communication. Okay, which means that it will transmit into the wireless medium as a electromagnetic waves. Okay, so you receive analog, process as an analog, and you produce output as analog. So everything is in analog. Everything is analog. So remember, analog signal is continuous over time. Okay, analog signal is continuous over time. So what you will learn in chapter 3. Okay, so chapter 3, remember chapter 3, this chapter is the largest chapter in your syllabus. Okay, and confirm it will come out in the test and final exam. Okay, so chapter 3 is divided into two parts, the first part and second part. First part is about amplitude modulation, which is AM. Okay, so the first subtopic is mathematical definition. Okay, and then bandwidth and modulation index calculation, power calculation, AM modulator circuit, okay, in the transmitter, and also AM demodulator circuit in the receiver. So modulator is a part of transmitter. Okay, it is a circuit. It is not a single component. It is a circuit. Okay, it is a group of circuits within the transmitter that do the process of modulation. Okay, demodulator is part of receiver, which do the process of demodulation. Okay, so demodulator is not a single component. It is consists of a circuit of components. Okay, and for your information, for example, here you will see that modulator is normally this is at the beginning of the transmitter side. Okay, and then after modulator there are many other processes before we can transmit the signal. Okay, demodulator is normally at the end of the receiver. Okay, so we receive the signal at the receiver, we do some processes, the last part is do the demodulation, and then we provide the output. Okay, so you will see later about this. And then what? So finish part 1. Okay, and your test later will come out until power calculation. Okay, until power calculation. This is for test questions. Okay, so test question will be after the mid-sem break. Okay, there are gonna be 3 questions. First question is for chapter 1, second question for chapter 2, third question is for AM until power calculation. Okay, and then what? So AM is under the category of medium wave. Okay, medium frequency, medium wave frequency, MF. Okay, medium frequency. So the range of frequency is around 5 kilohertz. Okay, until 1.6 or 1.7 something. So it depends on the type of standard. Okay, AM has a few standards. Okay, AM has a few standards. Kilohertz. Okay, 17xx. So from 500 something kilohertz until 17 something kilohertz. So AM has a few set of standard frequencies. Okay, so the range is around this range of frequencies. Okay, and if you want to see this frequency, you can see from your radio. If you have a radio at your home or in your car, for example, if you tuned to the AM, and you see the range of frequencies is around this frequencies range. Okay. And then what? Part 2 is angle modulation. So angle modulation, this is related to frequency modulation and also phase modulation, PM. Okay. So FM is the commercial radio that we always listen almost every day. So I listen to FM radio in my car during my when I drive to work and also to go home. So I listen to FM radio. For example, like Surya FM, Era FM, Hot FM, and etc. Okay, and this one, so both of these are related to each other. I can say that both of these is like a twin brothers. Okay, I can say that both of these is like a twin brothers. Okay, you will see later why. Okay, so the range of frequencies is between 88 megahertz until 108 megahertz. Okay, so if you see in your radio, okay, if you have radio, you see that for FM the range of frequencies is between this. So you can find a radio station between this range of frequencies. Okay, and for part 2, the subtopics are similar, are the same as part 1. So you will learn subtopic 1, 2, 3, 4, and 5. Okay, and 5 similar to the first part. Okay, similar to the first part. Only this is using FM. Okay, angle modulation. Okay. Okay, introduction. There are 3 properties of analog signal that can be varied or modulated by information signal. Okay, so there are 3 properties. As I mentioned before, modulation is the process of changing the characteristic of the carrier in accordance with the amplitude variation of the input signal. Okay, so what are the characteristics that will change during this process? So there are 3 characteristics. The first one is the amplitude. Okay, second is frequency, and then the third is phase. Okay, so as I draw previously, for example here in the transmitter. Okay, so this is the input. Okay, input message. Okay, we call it as information signal. Okay, so you will see that the input has a few names given in your lecture notes. Okay, so this I assume this is the first one. Okay, I will show you later what are the other names for information signal. Okay, so the input information signal or the message signal or modulating signal. So there are a few other names given for the input in your notes. Okay, so this will modulate with the carrier. Okay, analog carrier. Okay, so both signal will mix and modulate inside the transmitter, inside the modulator. Okay, so carrier and information info signal will modulate in the modulator. Okay, so the modulation process will change the characteristic of the carrier in accordance with the amplitude variation of the input message or information signal. Okay, so you see that at least for the modulation process, at least we need 2 input. One input message, one information signal, and another one is carrier. Okay, and actually you can have many info. You can have many and one carrier. You can do that. Or you can have many input, many carriers. Okay, so these are the high level modulation process. And in your syllabus, we only focus on one input message, one information, and one carrier signal only, the fundamental. Okay. So high level modulation techniques is not included in your syllabus, so don't worry. Okay. So for example, amplitude modulation, AM, varies. Amplitude modulation is the process of changing the amplitude of the carrier in accordance with the amplitude of the message signal or the input. Okay, so when the amplitude of the carrier change in accordance with the amplitude variation of the input, this is what we call as amplitude modulation. So you will produce AM signal at the output here. Okay, AM signal. And then what about frequency? Okay, so frequency and phase modulation are both forms of angle modulation. Okay, where the frequency or phase is varied according to the message signal. Okay, so frequency modulation, FM, is the process of changing the frequency of the carrier in accordance with the amplitude variation of the input signal. Okay, we call it as FM. So if the frequency of the carrier change during this process, so we call it as FM. So you will produce FM signal. Okay. And then what? Phase modulation. Phase modulation is the process of changing the phase of the carrier in accordance with the amplitude variation of the input message. Okay. So if this process change the phase of the carrier, fasa carrier, so we call it as PM. And you will produce PM signal. Okay. And then what? Both are often referred as frequency modulation, although there are actually distinct between the two, because changing the frequency change the phase and vice versa. So both FM and PM are commonly referring as FM. Okay, commonly referring as FM in practical case. Okay, why is it like that? Because when you do the process of modulation, when you change the frequency of the carrier, you are indirectly change the phase of the carrier. So FM and PM is actually happen at the same time. Okay, so that's why they are related to each other. So that's why previously I said that both FM and PM like twin brothers. Okay, they are related to each other. Okay, you will see later about this statement in part 2. Okay, so modulation, in radio communication, modulation means combining. Okay, modulation, of course, it is combined, but it is not just combine. Combine is another process. Modulation is also involved combine, but it will change the characteristic of the carrier. Okay, so the message signal which we want to send to some radio frequency carrier signal. So modulation is the process of modifying the characteristic of one signal, which is the carrier, in accordance with some other characteristic of another signal, which is the message. So carrier mix, modulate with input message to produce the suitable signal for transmission. Remember, we do the modulation process so that we can transmit the input signal into the medium suitable for long distance transmission. For example, your mobile phone. Okay, for example, the easy example is your mobile phone. Okay, so when I want to transmit my voice, okay, I want to talk to you. You are now at home, which is kilometers away from me. So how can I call you using mobile phone, so that how can I transmit my voice using the mobile phone? Okay, so mobile phone will modulate my voice with the carrier frequencies signal. Okay, and it will produce a signal at the output that is suitable for transmission. Okay, but remember, this mobile phone does not use FM. Okay, this is using a 4G LTE. Okay, so the concept is the same. So this mobile phone will modulate my voice, okay, and produce electromagnetic waves that is suitable for transmission. So that electromagnetic waves has a higher frequency compared to my voice frequency, which is in the radio frequency range. Similar with this one, so you modulate, for example, my voice you want to send as a FM, for example. So you change my voice frequency, you translate into a radio frequency, so that's suitable for to transmit in the wireless medium for long distance transmission. Because if using just my voice, I cannot transmit my voice a long distance to you by not using anything. Okay, I need something to modulate my voice so that it can be transmitted across the wireless medium. Okay, so you will see later that the carrier signal has higher frequency compared to the input message. The carrier signal is within the range of AM or FM. Nanti kita akan lihat. So the information message is usually known as the modulating signal. So you see that there's another names. Okay, so here is message signal, which is number 2. Another one is modulating signal, number 3. I just gave the number for different kind of names given to the input. Okay, so modulating signal is the input. Previously is the information signal, also input. Okay, message signal also referring to the input. And then you will see later about a modulation signal, also referring to the input. Okay, so don't confuse with that. So the carrier frequency is usually higher than the highest frequency of the information signal to be transmitted. Okay, the highest frequency, the carrier signal has higher frequency compared to the highest frequency of my voice, because my voice is not a single frequency, it has a few sets of frequencies range. Okay, so carrier signal mestilah lebih besar daripada frequency message yang tertinggi. Okay, amplitude modulation. Amplitude modulation is the process of changing the amplitude of the carrier in accordance with the instantaneous value of the modulation signal. Again, this is the input. What number is this? I'm sorry, 4. This is number 4 lah. Okay, okay. So amplitude modulation is the process of changing the amplitude of the carrier in accordance with the amplitude variation of the input message. Okay, so AM is relatively inexpensive, cheap, okay, low quality form of modulation that is used for commercial broadcasting of both audio and video signals. So actually we can transmit video signal using AM, no problem. Okay, so AM is also used in two-way mobile radio communications such as citizen band radio, CB radio. So AM modulators are non-linear device. Okay, you have 2 input at least and 1 output. Okay, what is the 2 input? 2 input is 1 input message and 1 carrier. At least you need to have 2 input. Okay, and you produce 1 output. Modulating signal and the carrier signal will mix together. So this is the related to this input. You need to the 2 input. So one is carrier, another one is modulating signal. So modulating signal will modulate the carrier signal so that the information contained in the modulating signal can be efficiently radiated by antenna through the free space at radio frequency. So the radio frequency, as I mentioned earlier, for AM around 5 XX kilohertz until 17XX kilohertz, depending on the type of AM standard that you used. So AM has a few standards range of frequencies. Okay. So modulating signal VMT. So we give the parameter of input or the modulating signal as VMT. So VMT is a function of time. Okay. So this is a function, not a constant. Okay. So you see that this is a small letter of V. So this is referring to the function. If you see V, capital V like this is a constant parameter. Okay, the way we write the parameter is a capital letter for constant, small letter for function. Okay. So VMT may contain single frequency or multiple frequencies such as human voice. So there are several types of amplitude modulation. The most commonly used is amplitude modulation double sideband full carrier, or AMDSB-FC, double sideband full carrier, or simply known as AM. So later in your notes, when you see AM, the word AM, this is referring to double sideband full carrier. Double sideband full carrier is the oldest technology of AM. Okay, the oldest of AM system is double sideband full carrier. Ini yang paling tua lah, double sideband full carrier. AM yang paling tua adalah double sideband full carrier. Okay, and there are many other types of AM, such as double sideband suppressed carrier, double sideband reduced carrier, single sideband, and also vestigial sideband. So AM has some family members. Okay, the oldest is a double sideband full carrier, and there are many other AM such as suppressed carrier, reduced carrier, single sideband, and vestigial sideband. So we will see about this later. So the other types of AM, okay, the other type of AM try to improve the double sideband full carrier. Okay, for certain kind of applications. Advantage of AM. So again, when you see the word AM, so this is referring to double sideband full carrier. Okay, so double sideband full carrier is has a simple design circuit, effective for signal transmission, inexpensive, cheap. Okay, and it can be used for AM radio broadcast. For example, radio broadcast, TV broadcast, aircraft communications, CB radio, and computer modem applications. So there are many other applications for AM. Disadvantage of double sideband full carrier, DSB FC. So what are the disadvantages? Okay, so double sideband full carrier, wasted power in the carrier component. Okay, because it does not carry any information. So you will see about this later. So because of this, it is categorized as not efficient in some application, not all application. In some application, it is categorized as non-efficient. Okay, even when M equal to 1 during the ideal case, 2/3 of the total power belongs to the carrier, where carrier does not carry any information. So I will explain about this statement. I will explain about this statement later when we learn about the power calculation. Okay, I will show you why it is wasted of power. Kenapa membazir power? Why? Okay, you will learn about this later in the power topic. Okay, power calculation topic. Okay, so this is the modulator block diagram. So we have the input and we have the carrier signal, and it produces AM at the output. Okay, so this is the equation. Okay, this is the equation. So don't worry, this is simple. Okay, this is not complex engineering maths. Okay, so the calculation only involve trigonometry calculation. So let's the carrier signal assign as VCT. So VCT is for the carrier, VMT is for the input message or the modulating signal. Okay, so the function of carrier VCT is equal to VC sine 2 pi FCT. Okay, so VC here is the peak amplitude. This one, VC, this one is peak amplitude. And then what? VMT is equal to VM sine 2 pi FMT. This is the peak amplitude and this is the frequency. Okay, so how to, you see that in your lecture notes, we have simplified the input and the carrier as a sine wave. And if you read other literature books, some of them use cosine. Okay, some of them use cosine, cos. So no problem. Okay. However, you should understand that in the real world scenario, okay, in the real world scenario, the input signal is not in the form of sine wave. Okay, this is just for the learning process. Okay, dalam dunia sebenar, input itu bukan dalam bentuk sine wave. It can be in any kind of signal that has a complex equations. Okay, but for the purpose of learning the fundamental, we use a sine or cosine. Okay, so if you see the graph, how does this signal looks like? So it is a sine wave. Okay, sine wave. And for example, this is a VCT. So the peak amplitude here is VC. Okay, the peak amplitude here is VC, and the peak amplitude at the negative side is also VC, but negative VC. Okay, similar for the VMT. Similar for VMT. Okay, so this is VMT. So the peak amplitude is VM. Okay, VM, and the negative peak here is also VM, but it is negative VM. Okay, and then what? Modulating signal use peak value of the carrier as a reference point. Modulating signal value adds or subtract from the peak value of the carrier. Okay, so that means this process of modulation will add and subtract the amplitude of the carrier in accordance with the input variation. Okay, so amplitude of the carrier change up and down in accordance with the variation of the input, in accordance with the amplitude variation of the input. Okay, so there's another parameter what we call as the V envelope. So I will show you about envelope later. What is how does the envelope looks like? Okay, so the word envelope because the signal looks like it is within a specific envelope, as if. Okay, so that's why the name is envelope. Okay, so V envelope is a function of time, which is equal to VC plus VMT. So this VC is the peak amplitude of the carrier. VMT is a function. So if we elaborate this equation, it becomes VC plus VM sine 2 pi FMT. This is the envelope function. And when you want to define the final equation of AM, it is equal to envelope equation multiplied with sine 2 pi f ct. Okay, so you multiply this, you will get the final equations for AM. Okay, so when you multiply envelope equation and sine 2 pi f ct, what you will get is this one, Vc sine 2 pi f ct plus Vm sine 2 pi fmt sine 2 pi f ct. Okay, and this component we can further elaborate using trigonometry identity. So according to trigonometry identity, sine A and sine B is equal to cos A minus B over 2 minus cos A plus B over 2. So what is A, what is B? Okay, so A use the higher frequency compared to B, so that you are not getting negative frequency. Okay, so you see that it becomes like this. Okay, Vc sine 2 pi fct, which is the carrier, plus Vm over 2 cos fc minus fm. This is for A minus B. Okay, A minus B. Okay, and minus Vm over 2 cos 2 pi fc plus fm. So this is A plus B. Okay, so if you see from here, this minus here is the low frequency signal because you subtract. So this is the lower sideband, and we have another one is at the higher frequency, fc plus fm, which is what we call as the upper sideband. Okay, so when you want to draw the frequency spectrum, okay, if I want to draw the frequency spectrum, which is voltage versus frequency, for example, okay, so I can draw like this. Okay, so this is fc, this is fc plus fm, okay, and this is fc minus fm. Okay, fc minus fm, and the amplitude is Vc, this is Vm over 2. Okay, so how do I get these values? This is from the equations. So I take the amplitude Vc at frequency Fc, the amplitude of lower sideband, so this is the amplitude of lower sideband located at Fc minus Fm, which is this one. Okay, and then the amplitude of upper sideband, this one, located at Fc plus Fm. This is the upper frequency, upper sideband. Okay, so this drawing is what we call as frequency spectrum. Okay, frequency spectrum diagram. So the effect of modulation is to translate modulating signal into the frequency domain that is reflected symmetrically above the carrier frequency. Okay, so later you're going to see more picture about this. So normally in the test and final, we ask student either to draw frequency spectrum or waveform. Okay, what is AM waveform? I will show you. This one. Okay, this is what we call as waveform. Okay, it is a time domain graph. Okay, waveform is a time domain graph. So you see that from here, this is the carrier. Okay, originally the carrier has a Vc of 10 volt, okay, and a certain frequency. Okay, you can calculate the frequency by dividing the time for one complete cycle. Okay, for one complete cycle. So this one has a few cycles, okay, within 0.05. So for example here, the input message okay. Okay, for example, the second picture here is the input message. So this is a VCT. This is DMT. Okay. So we have VM, peak amplitude is 5 volt, and it can complete one cycle within 0.01. Okay, one cycle 0.01 second. Okay. And this is the VAMT, the resulting AM. Okay, VAMT. Okay. So you see that what happened to the signal AM? You see that initially the carrier has a constant amplitude. The amplitude remains the same. But after the modulation, the amplitude of the carrier changed. The up and down of the amplitude, carrier amplitude changed in accordance with the input message. Okay, and if you see from here, the maximum voltage is more than 10. Okay, this is around 15. So the resulting output, the maximum gonna be VC plus VM. So you're gonna get 15 volt at the output maximum. Okay, and for your information, the red color line, okay, the red color line at the positive and negative side, okay, the red color line. This red color line is actually an imaginary line. It does not exist in the real world. So we just draw this red line to show that this is the envelope. Okay, this is the positive envelope and this is the negative envelope. Okay, negative envelope at the negative side. So this picture is like a symmetrical around 0. So you have the positive side and negative side. Okay, so the red color is an imaginary line actually. Okay, the red color line is the imaginary line to show that this is the envelope shape. Okay, so the envelope shape follows the shape of the input message. Okay, the envelope shape follows the input message shape, which is the sine wave. Okay, so this is the waveform. Okay, waveform is graph in time domain, and frequency spectrum is in term of frequency domain F. Okay, so when you are asked to draw AM spectrum, you need to draw this. Okay, so you have lower sideband, carrier component, and upper sideband. So this is voltage versus time or power versus time. Okay, sorry, voltage versus frequency or power versus frequency. Okay, and when you ask to draw AM waveform, you need to draw this picture. Okay, so in the test or exam, you need to be able to draw quickly. Okay, this graph. So I will show you how to draw in a simple way. Okay, because during the test or final exam, you don't need to use ruler to draw the waveform. You can sketch using pencils or pen. No need to use ruler. Okay, tidak perlu menggunakan ruler. I will show you how to draw later. Okay, and this is about the frequency spectrum and the bandwidth. So we want to calculate the bandwidth for the AM spectrum. So in order to calculate the bandwidth, you need to know or you need to understand, to know or to draw the frequency spectrum so that you can see how much is the bandwidth. So the bandwidth is calculated by subtracting the highest frequency to the lowest frequency. Okay, so it is equal to 2 FM. So how do I get 2 FM? So bandwidth is equal to FC plus FM minus subtract with lower sideband. Okay, so it is equal to FC plus FM minus FC plus FM, which is equal to 2 FM. Okay, so that means the distance, okay, the distance here is FM, and also distance here is FM. Okay, so you get 2 FM. Okay, so this is the bandwidth for double sideband full carrier, DSBFC. Okay, several baseband signals may be transmitted simultaneously on different carrier frequencies, multiplexing, provided the sideband do not overlap. Information is in the baseband, information signal is duplicated in the lower sideband and upper sideband, and the carrier conveys no information. What is this about? Okay, so this statement say that information contains within the sidebands, which is the lower and upper sideband, and the carrier does not convey any information. Okay, so like this. So the statement says that, so I delete this one. The statement says that information contains within the lower sideband and upper sideband. Both lower and upper sideband carries the same information, like a duplicated information. Okay, whereas the carrier does not contain any information. So you can assume like a empty box, for example. Okay, it's like a container without any information. The information are in the sidebands. Okay, so if you see from here, actually when you want to use double sideband full carrier, you are as if when you are transmitting the double sideband full carrier from transmitter to the receiver, it is as if you transmit twice. Okay, seolah-olah macam you hantar dua kali. Why? Because the information in the lower and upper sideband are same, like a duplicated information. So it is as if, okay, as if you are transmitting twice. Okay, seolah-olah macam you transmit twice. So, okay. So, you see that for double sideband full carrier, we have 3. Okay. Later, you're going to see that how to improve this so that we can reduce the power requirement, or we can reduce the bandwidth requirement. Okay. And for the efficiency, normally we see from two perspectives about power. Okay, some application has a limitation of power. Okay, some application requires low power. Some application. Okay, some other application doesn't matter. Okay, other application does not matter. Maybe other application has no problem with higher power, but there are some applications require less power. Okay, and then you can see from the perspective of bandwidth for improvement. Okay, some application requires low bandwidth. Some other application does not require low bandwidth. Okay, so when we want to design system, normally we see from these two perspectives normally. Okay, so in terms of this, for double sideband full carrier, we are transmitting more power. Why? Because the carrier does not carry any information, does not contain any information. So if we transmit the carrier component, this one, we are actually wasting a lot of power. because this does not contain any information. Okay, and then what about bandwidth? So bandwidth for double sideband full carrier is considered as large for certain application. Okay, because we use 2 FM. Okay, and we are transmitting duplicated information. So actually we are wasted the bandwidth for some application. Okay, so later you're gonna see double sideband full carrier can be improved with other double sideband with other AM family member. Okay, like reduced carrier, suppressed carrier, single sideband and others to improve both of this. Okay, we're gonna see about that later for improvement. Okay. Okay. So before we move to modulation index, maybe I want to show you how to draw. Okay, how to draw the AM waveform. Okay, how to draw the AM waveform. This one, yeah. Wait, how to draw? Maybe I can add one slide additional. Okay. So I want to show you how to draw AM waveform. How to draw this? Okay. So AM waveform. Okay. If AM spectrum I already show you. This one, AM spectrum. Okay, AM spectrum. Okay, this is for AM spectrum, voltage versus frequency or power versus frequency. It is in the frequency domain. But for the waveform, it is in time domain. Okay, waveform is in time domain. So, how to draw? Okay, so when for the question of drawing, normally we will see two things. The first one, either you draw correctly, and the second one is whether you label correctly. So draw correctly and label correctly, so you will get full marks. Okay, so how to draw AM waveform? So I will draw like this, the axis. I will draw the axis first. Okay, you don't need to use ruler, jangan guna ruler, wasting time. Okay, and then what? I will draw imaginary line. Okay, so if you are good enough, you don't need to use imaginary line. So I normally use imaginary line like this. This is just a reference for me. Okay, so this so I estimate the distance must be the same. So positive and negative side. Okay, imaginary line. Okay, and I also draw another imaginary line of sine wave. Center at the green line here. Okay, so this is the envelope shape, positive envelope. Okay, and then what? I also draw imaginary line at the negative side. Okay, this is a sine sine wave. So it is reflection of the positive side, reflection of the positive side. Okay, and then what? Then I will draw the the wave. Okay, I will draw the wave like this, starting from the above here, go down, up, Okay. So draw correct. Okay. So the output AM waveform follows the correct shape. Okay. Then what? Then I want to see the labeling. I need to label correctly. So first of all, label the axis. Okay. Sorry. Label the axis. So this is voltage versus time. So correct. Okay. Another one. Normally I also want you to label the maximum and minimum. Okay. Maximum and minimum we will learn later. We will learn later about maximum and minimum. Okay. So here is Vmax. The maximum. Over here is this one. Vmin. V maximum and V minimum. Okay. Similar with this one is V negative V max. Okay, negative V max. And over here is V min, negative V min. Right? Negative V min. Okay. So correct drawing, correct labeling, so full marks for drawing. So you see that I don't use ruler because it's gonna waste a lot of time during the test or final. So you need to practice at home so that you can draw correctly in a faster way, so that you are not wasting a lot of time. Okay. So now let's look at the modulation index. Modulation index M is defined as a parameter which determines the amount of modulation. Okay. So for proper AM to occur, VM, this is the peak amplitude of modulating signal, and this is the peak amplitude of carrier. So the peak amplitude of the modulating signal or the input message must be less or equal to the peak amplitude of the carrier. And we calculate the modulation index M equal to Vm over Vc. It is a unitless parameter. And we can also calculate in terms of percentage, where we multiplied with 100%. Okay. So you see that be careful that this is a unitless parameter and the other one is a percentage parameter. And there are a few cases of careless mistakes. Okay, based on the previous experience. Okay, based on the previous experience, student did correct mistakes like this. The first one is like this. What they did is, for example, Vc over Vm. This is wrong. Okay, this is wrong. Another careless mistake is like this. They did in terms of function. For example, Vm t divide with Vc t. This is also wrong. Okay, be careful. Okay, so both Vm and Vc are the peak amplitude. Okay, are the peak amplitude. So based on this modulation index, okay, we can distinguish three different scenarios of AM. Okay, so the first scenario is what we call as undermodulated AM, where M less than 1. And then ideal AM for M equal to 1. And overmodulated for AM for m more than 1. So less than 1 undermodulated, equal to 1 is ideal FM, over than 1 is what we call as overmodulated AM. Okay, and we have asked these questions in the previous semesters. Okay, pernah ditanya. So in the previous semester we asked students to explain the type of scenarios in amplitude modulation. Okay, so we have undermodulated, ideal FM, and also overmodulated FM, overmodulated AM. So explain using suitable diagrams. Okay, that kind of question. Okay, so the answer is here. Okay, for the first scenario, m less than 1. So this is what we call as undermodulation, where Vm is less than Vc. So the signal strength obtained at the receiver is not exactly the same as the signal strength at the transmitter. Of course, when the signal has traveled at long distance, it's gonna be attenuation. Okay, the signal will attenuate due to the distance and due to the other obstacles. Okay, crash with other obstacles in the medium. Okay, and there is no distortion to the signal, just reduce in signal strength. So undermodulation is good. Okay, undermodulation is good, and in most practical cases we use undermodulation. Okay, in most practical cases we use undermodulation. So you see that the positive and negative envelope are separated further away like this. And for ideal modulation, this is ideal. Ideal modulation m equal to 1. So this is when Vm equal to Vc. Okay, Vm equal to Vc. So this will produce the greatest output at the receiver without distortion. Maximum information signal amplitude will be transmitted. More information signal power is transmitted, producing stronger, more intelligible signal. That means we are producing higher signal power that carries the information, because Vm is higher. If Vm is higher, that means the power that when we convert into power, the power would be higher that for the component that carries the information. Okay, which is good. Okay, so it is hard to achieve, especially when the modulating signal amplitude varies randomly over a wide range of frequency. Only peak of the signal will produce 100% modulation. So what are the difference? The difference, you see that here the envelope, okay, the envelope is connected like this, is touching like this. So these are the difference in terms of waveform. And if you see from the perspective of the total amplitude, okay, the amplitude is higher. Okay, the amplitude is higher, bigger like this. Okay, compared to the undermodulation. Okay. The third scenario is what we call as overmodulation. Overmodulation when m more than 1. So that means Vm is larger than Vc. Okay, Vm larger than Vc. This will cause distortion. Negative peak have been clipped off. Negative peak of the envelope has been clipped off. The original shape of the signal is destroyed. So how does the clip off looks like? So the clip off is this one, clip off. Okay, so clip off with the positive part. It clip off with the negative and positive peak has been clipped off. So you see that the original shape of the signal is destroyed. So this has caused distortion. So we don't want this to happen. Ideally, we don't want this to happen. Okay, in practical cases, normally under modulation or ideal modulation. Okay. This one. So before we continue, can I get your response? Are you still there? Can you hear my voice? Can you see my screen?
Ya, Doctor.
Okay, okay. Thank you for the response. Because I afraid that I talk alone. Saya bimbang saya cakap seorang. Okay. Okay, so okay, so modulation index can also be calculated directly from the AM wave. So previously we calculate M equal to Vm over Vc, but actually we can also calculate based on the given waveform. So how to do that? In order to do that, first we need to understand a few sets of parameter. We need to understand what is Vmax, what is Vmin, where is Vm, and where is Vc. Okay, and if you see from this graph, okay, Vmax is from the x-axis until the highest amplitude. So this is what we call as Vmax. Okay, and Vmin is from the x-axis until the minimum peak on the positive side, which is this one. Okay, the minimum peak. So this is Vmin. Okay, and then what? The voltage, the carrier voltage is from the x-axis until the reference line that I drawn previously in my picture. Okay, if you remember this picture, okay, the green color line, what is actually referring to Vc. So what I've drawn is actually the Vc. Okay. So from the x-axis until the reference line, this is the Vc. And from here, from the reference line, we see that a sine wave, okay, which follows the information signal. Okay, the up and down. The up and down of the carrier follows the amplitude variation of the input. Okay, so here is the Vm. So positive peak. So this is from here until above. This is Vm. Okay, so this is this is Vm. This is Vm, and also this is Vm. Okay, so Vmax is actually equal to, if you see from this picture, equal to Vc plus Vm. Okay, what about Vmin? So Vmin, if you see from this picture, it is actually equal to Vc minus Vm. Okay, so from here we consider only one side. We are not consider the other side. We only consider only one side, either positive side or negative side. Okay, and if you see from here how to calculate Vm based on the given max and min. So Vm can be calculated using Vmax minus Vmin divided with 2. Vc is equal to Vmax plus Vmin over 2. Okay, so remember that M is equal to Vm over Vc. Okay, so what you can do is like this. So Vm over Vc, so this is equal to Vm is Vmax minus Vmin. Okay, Vmax minus Vmin divide with Vmax plus Vmin. Okay, and because we can cancel out this 2. We can cancel out when we divide Vm and Vm and Vc, we can cancel out the 2. So that's why I get Vmax minus Vmin divide with Vmax plus Vmin. Okay. So it's already shown here. Okay, it's already been shown here. Okay, Vmax minus Vmin divide with Vmax plus Vmin. Okay, and we can also consider in term of peak to peak values. Boleh juga kalau kita kira peak to peak. Okay, so if you want to consider peak to peak, from positive peak to negative peak, we just need to change the maximum and minimum into peak to peak value. So that means M equal to Vmax peak to peak minus Vmin peak to peak divide with Vmax peak to peak plus Vmin peak to peak. Okay, so we get in term of maximum and minimum. Okay, and for your information, we have asked this kind of question in the test and final exam. Okay, where we give the question in term of AM waveform like this, and we give the maximum value. Okay, and we give the maximum value and the minimum value only. Okay, we give the graph like this and we label the maximum and minimum. Okay, so this is the max, this is the minimum. So from there, students need to find the modulation index, to find the Vm, to find the Vc, to calculate the power and so on. Okay, so we have asked that kind of questions before. Okay, we give the waveform, we give parameters max and minimum. From there, you need to be able to understand that the given value is actually the maximum and minimum. Then you can do the calculation to find the modulation index, power, and etc. Okay. So if you have questions, please ask. If you don't have question, I will move to the next topic. Okay, kalau ada soalan, sila tanya, sila tanya. Otherwise, we will move to the next topic. Okay. Okay, so next. Okay, so if you have question, please ask. Otherwise, I will move to the next slide. So what you need to understand from here is that I think the most important question is this one. Okay, and you need to know how to calculate a Vm and Vc based on the given Vmax and Vmin. Okay, so Vmax is equal to Vc plus Vm. Vmin is equal to Vc minus Vm. Okay. So therefore, from the given equation, okay, VAM can be defined as Vc sine 2 pi fct. So this is what we have learned previously in the previous slides. Okay, this is what we have learned in the previous slide, that Vc sine 2 pi fct. So this is the carrier, this is the LSB, this is the USB, upper sideband. Okay, and from here we know that M is equal to Vm over Vc. So we can change Vm into MVc. Okay, so we can elaborate, we can define the equation as in term of Vc and also the modulation index. So again we rewrite the equation. Okay, we rewrite the equation to become Vc sine 2 pi fct plus MVc, because Vm is equal to MVc. Okay, MVC over to lower sideband, and also MVC over to upper sideband. Okay, so you can either write these AM equations or this one, no problem, tak ada masalah. Okay. Okay, let's do the example. Suddenly I feel tired. Okay, so no problem, let's continue. Okay, so let's look example 3.1. Okay, example 3.1. So this is a calculations example. So I think you will like this. Okay, you will like this example. Okay, saya rasa kamu akan suka. Okay. Example 3.1, a carrier signal with a peak voltage of 2 volt. So the keyword here is carrier signal with peak voltage. So this is referring to VC. Okay, is amplitude modulated. So the carrier is amplitude modulated with another signal that has frequency of 10 kilohertz sine wave. So what is this actually? So this is another signal that modulate the carrier, and the frequency is this. So this is actually referring to the frequency of the modulating signal or the message. Okay, the modulation voltage. So this is referring to the input. Okay, that means it has an effective value of 750 millivolt. So that means this is VM, but in terms of RMS. Okay. So the question asks, find the percent modulation M. Okay. Remember, M is equal to VM over VC. So peak amplitude of VM over peak amplitude of carrier. Okay, so how to find VM peak? This is I can say that this is peak value actually. So VM peak is actually equal to the peak value equal to square root of 2 okay, so before that sorry, so VRMS, so before that I'll show you remember VRMS is equal to VM peak value divide with square root of 2. So if you want to find peak value, that means VM peak divide with equal to square root of 2 multiplied with VM RMS. Okay, square root of 2 multiplied with VM RMS. Okay, so this is equal to so let's calculate how much is the peak value, and this is actually carrier peak also. Remember, modulation index, we use the peak amplitude. Okay, so that means this is equal to square root of 2 multiplied with 750 millivolt. Okay, so here you will get try use calculator. Okay, square root of 2 multiplied with 750 milli. Okay, so you get 1.06. Okay, so from here I can calculate the modulation index, which is equal to M equal to VM peak. So VM peak divide with VC peak. So this is equal to 1.06. So the question asks in terms of percent, so I need to multiply with 100%. Divide with 2 times 100%. Okay, so how much is this? So this is 1.06 divided with 2 multiplied with 100%, so you will get 53%. Okay, so as in the answer here, okay, 53%. Okay, why .02? Because this is if you multiplied with square root of 2 multiplied with 750 milli, you get 1.0606. Okay, 1.06 multiplied with divide with 2. Okay, so I think if you do like this, 1.0606, okay, okay, 1.0606. Okay, 06. So you get 53. Okay, same. Okay, same answer. And then what? And then you need to calculate the the question asks how much is the instantaneous voltage of positive and negative envelope when the 10 kilohertz of sine wave has completed 68 microsecond of its cycle. Now, so how to do this? Remember V envelope. Okay, V envelope is equal to this one. Again, if you move to the previous slides, this one. So it is actually VC plus VMT. Okay, and actually we can put plus and minus in front. Okay, actually we can put plus and minus at the front side as a signage. Okay, it has a positive and negative value. Okay, so therefore so I put a positive and negative signage to show that there is a positive and negative values for the envelope, upper and lower. So actually like this, plus and minus. I put bracket VC plus VM sine 2 pi FMT. Okay, FMT. Okay, so this is equal to plus minus bracket 2 volt so 2 plus VM is 1.0606 sine 2 pi FM is 10 kilohertz times 10 kilo times 68 times 10 power of minus 6, 68 microsecond. Okay, and then close bracket. Okay, okay, so if you see so if you want to do this, first of all you need to change your calculator into radians. Okay, change your calculator into radians, and then what you can do is you can calculate in this bracket first. 2 pi okay, try use your calculator. 2 pi times 10k times 68 micro Okay, I get 4.272566, and then I sign of answer, so I get negative 0.9048. Okay, so it is actually like this, so negative plus minus 2 plus 1.0606 in bracket minus 0.9048, 0.9048. Okay, so this is equal to plus minus how much? So 1.0606 multiplied with 0.9048, so I get negative so 2 minus 0.9596, 0.9596. Okay, so 2 minus 0.9596, so I get here is around plus minus 1.40404004. What is this? Volt. Okay, in terms of volt. So similar with the given answer. Okay, similar with the given answer. So you get here is 1.04, and it has a positive and negative side. Why is it like that? Okay, so let's look in the given graph. So this graph is actually for question number 3. Okay, question number 3. So if you see from here, time versus amplitude. So 68 microsecond, 68 microsecond is somewhere around here, okay. So you see that if you draw a straight line, it will cross at positive and negative of the envelope. Okay, so 68 is around here, 68. Okay, and it cross at 1.04, okay, 1.04, and also minus 1.04, okay, plus and minus 1.04. Okay, because this is double sideband, so we have upper and lower envelope. Okay, so how to draw? Okay, how to draw? Because the third question illustrate the resulting AM waveform. So how to draw this? Okay, wait, I will show you. Okay, again we will draw again like before. Yeah. So I will add additional slide. Okay, I will add additional slide over here. Okay, so draw the resulting AM waveform. Okay, so what you need to do is, first you need to know that VC is equal to 2 volt, and VM is equal to 1.0606 1.0606 volt. Okay, and then what? From here, actually I can calculate the max and minimum. Vmax is equal to 2 plus 1 point, okay, yeah. So VC plus VM, so this is 2 plus 1.0606, so this is 3.0606 volt, and V main is equal to VC minus VM, so this is 2 minus 1.0606 equal to 0.9394. Volt. Okay, so when I want to draw, okay, why I find max and min? So that I can do the labeling correctly. Okay, so that I can do the labeling correctly. So you see that first of all I will do the I will do the axis. Okay, I will do the axis. Okay, the axis is voltage versus time. Okay, and another thing is that I will do a reference point. I will do the reference of VC. VC is around here. Okay, this is just a reference. And then another reference of sine wave, a dotted line, actually dotted line. Similar with here. And then I will draw. Okay, so I will draw okay, correct drawing. Now I will label. I will label. So I will label. What color should I label? Okay. So here is the maximum is 3.06. So I just write the value 0.06. Okay, and the minimum here is 0.9394. Okay, and here is negative. Minus 3.0606. Okay, so full marks like this. Okay, so this is the way you can do. This is the way you can draw the AM waveform using the given parameters. Okay, any question you can ask, boleh tanya. Any question you can ask. Okay, so during the exam and test you don't need to add how much is the value of time. Okay, we know that this is a voltage versus time, and you draw correctly and you label correctly. At least you have the maximum or minimum label. Okay, have question. If you have question, please ask. Otherwise I will move to the next slide. Okay, kalau ada soalan boleh tanya. Otherwise I move to the next topic. Okay, so no question. Students, are you still there? Someone respond, please.
Yes, Doctor.
Okay, thank you for the response. So you are still there. That's good. So if you understand, that's good. So no question. If you don't have question, I will move to the next topic. Okay. If you have question, please ask anytime, no problem. I will explain again so that you can have more understanding. And remember, when you draw, don't use a ruler. Don't waste time. Okay, don't waste time, because we don't want to see a graph that is very nice. Sorry, very, what we call a pretty graph. We just want to know that the graph is correct, and you label correctly. That's it. Okay, I normally want to see two things: draw correctly and label correctly. That's it. Okay. Okay, the next topic is about power. Power, the equation of power still the same from before, now, and in the future. So persamaan power masih sama daripada dulu, kini, dan selama-lamanya. So the power equation is derived from the Ohm's law, which is a V equal to IR. Okay, so when you want to calculate the power, you can use the RMS or peak voltage. Okay, if you use the RMS voltage, that means it is V square over 2. V square over R. Okay, V square over R. And if you want to use peak amplitude, that means it is a V peak square divided with 2R. Okay, so you get power in terms of what? Okay. In the previous discussion, we assumed that the impedance of the antenna is unity. In the previous one, we assume, okay, so it doesn't matter if R equal to 1, that means you can just replace with 1. Okay, it depends on the value of R. Okay, so from the sideband voltage, we know that VLSB is equal to VUSB. Okay, both are equal, which is equal to MVC over 2. And the way we want to calculate the total power, so this is the total power for double sideband full carrier. Okay, so how to calculate the total power? First of all, you need to know the complete equation of AM. Okay, you need to know the AM equation first. Okay, so we have derived the AM equation previously, which is this one. Okay, we have derived the AM equation, and from here we know the spectrum. Okay, we know the spectrum, that the spectrum looks like this. This is V versus F. So the spectrum looks like this: FC at with amplitude VC, and also here. Okay, so this is FC plus FM, this is FC minus FM, and the amplitude here is MVC over 2. MVC over 2, MVC over 2. Okay, or you can write this as VM over 2. Also correct. Okay, either you want to use VMVC over 2, or you want to use VM over 2. Both are correct. Okay, either one. Okay, so from here, when you want to calculate the total power, okay, when you want to calculate the total power, you need to add all the power component you need to add all the power components. Okay, so therefore that means P total is equal to power of the carrier plus power of the lower sideband, power of the lower sideband plus power of the upper sideband. Why I do this? Because my frequency component, my frequency spectrum and my equation contain three components. I have the carrier, I have the lower sideband, and I have the upper sideband. So the way we calculate the power, we need to add all the power components. Remember that, okay? The way we want to calculate the total power, first define the equation. From there, you know how does the spectrum looks like, and you can calculate the power based on how many elements, how many components are there in the equation. Okay, so I go back to the slide. Okay, this one. So you see that here, so I put it here. PT is equal to PC plus P LSB plus PUSB. Okay, so PC is equal to VC square over 2R. Okay, PLSB, so PLSB is equal to MVC over 2 square divide with 2R. So it becomes like this, M square VC square over 4 divide with M square VC square divide with 4 times 2R. Similar with the other one, M square VC square over 4 times 2R. Okay, and from here actually you can see that this part, so this part and this part. Okay, so this is actually PC. So we can rewrite into this PT equal to P total equal to carrier power plus M square over 4 PC plus M square over 4 PC. And finally we get PT equal to PC multiplied with 1 plus M square over 2. Okay, so remember remember this is only true for double sideband full carrier. Okay, because we have 3 components. Okay, the general equation for power is this one. We add all the power component. Remember, okay, this equation is only for double sideband full carrier, where it has 3 components. Okay, and you're gonna see later, okay, you're gonna see later that another type of AM only has less than 3 components. For example, like the single sideband. Okay, I just show you earlier. You will see later, like the single sideband, we only have a carrier component and, for example, upper sideband. So this is FC, this is FC plus FM, for example. Only have 2 components. That means the total power for this is equal to PC plus PUSB. Okay, so if this is VC, for example, this is VUSB, for example, so it is equal to VC square over 2R plus VUSB square over 2R. You cannot use this equation, the equation below. Okay, so in general, so the general equation is for all kind of so for any power calculation we use this general equation. Okay, so so I draw a line here. Wait, okay, so we have seen here PLSB equal to PUSB. Why? Because they are equal. Equal to VM over 2 VM over 2. So how does we get the VM over 2? So VM over 2, remember VM over 2? VM over 2 is the, sorry, yeah. So Vm over 2 is from the spectrum, okay, or from the equation, which is the sideband amplitude, Vm over 2 or MVC over 2. Okay, so therefore we already know this. We already know this. So Vm over 2, which is the amplitude, the peak amplitude of the sideband. So square divide with 2r, or you can replace with MVC over 2 square over 2r. Okay, so you get m square over 4VC over 2r, which is m square over VC, m square VC square over 8r. Okay, so don't be confused. This is just to show the relationship of modulation index and the voltage and the carrier voltage. Okay, so it is m square VC square over 8r. Okay, this is for each of it. This is for PLSB and also PUSB. Okay, and then the statement below, if m equal to 1, what happened? This is during the ideal case. Remember ideal modulation, Vm equal to Vc, which is m equal to 1. So what happened during the ideal case, during the best case scenario? What happened? Okay, so P total becomes 3 over 2 of Pc. So how does this slide get this value? It is based on this equation, Pc plus 1 plus m square over 2. So if you replace m with 1, okay, so this is 3 over 2, 1 plus 1 over 2, so you get 3 over 2. So P total is equal to 3 over 2 of carrier power. Okay, so P total is equal to 3 over 2 of carrier power, or carrier power, we can rearrange the equation, so we get carrier power is equal to 2 over 3 of the total power. Okay, among the total power, 2 over 3 of the total power belong to the carrier component. Okay, 2 over 3 of the total power belongs to the carrier component itself. So what about the sidebands? So both sideband, lower sideband plus upper sideband, becomes the remaining of the total power, which is 1 over 3. The remaining for both sideband, upper and lower. Okay, and if you want to find each of the sideband power, we need to divide with 2. 1 over 3 divide with 2, so you get 1 over 6 of total for each of the sideband. So you see that the sideband power is small, very small, compared to the carrier power. Okay, and this is during the ideal case, the best case scenario. And if we look for the under modulation, during under modulation, PLSB or plus PUSB, the sideband's power becomes smaller, even less during the non-ideal case. Okay, because even during the ideal case, the sideband power is less. So during the non-ideal case, the total the sideband power will become much lower, which is not good. Okay, which is not good. And remember, class, ideally, okay, ideally we want the sideband power to be as high as possible. Ideally, secara idealnya kita inginkan sideband power ini sebesar yang mungkin. Why? Because the sideband contains information. Okay, we need to have higher power for the sidebands. The higher would be better. Okay, And for the carrier, you see that carrier 2/3. Carrier does not carry in any information, but it takes a lot of power, which is not good. Okay, ideally, we want the carrier power to be as low as possible. Okay, because the carrier does not contain any information. It's like an empty box. Dia macam seperti tin kosong yang mana tidak mengandungi sebarang info. Okay. So in practice, a carrier signal will be modulated by several signals simultaneously. The total modulation index or effective modulation index has to be calculated. Okay. So this is for single input message. So if you want to utilize the carrier, if you want to utilize the modulation process, we need to modulate with many input. So if we have many input, okay, we have many input and one carrier, we can increase the sideband power by doing the multiplexing. We multiplex many input and one carrier, and we can get the sideband power much higher, which is good. Okay, one of the method to increase the efficiency is to do the multiplexing process. We use multiple frequencies input. Okay, so this answer the previous statement about the disadvantage of double sideband full carrier. Okay, this prove the disadvantage of double sideband full carrier about the efficiency. Okay, so double sideband full carrier is less efficient in some application because most of the power belongs to the carrier, whereas the carrier does not contain any information. Okay, so we go back to the previous slide about the disadvantage. Where this one? Okay, this one. So the disadvantage has been proved in the power equation. Okay, we have seen in the power equation that most of the power belong to the carrier, but carrier does not carry any information, so it is not efficient for some application. Some application this method is not efficient because the carrier does not contain any information and it has a lot of power, it consumes a lot of power. Okay, even during the ideal case, okay, 2/3 of the total power belongs to the carrier. So how to improve this? We can use multiplexing, one of the method. Okay, multiplexing. Okay, so that we can utilize we can utilize the power of the sideband. We can increase the power of sideband by having many inputs transmitted simultaneously using one carrier. Okay. Okay, so I go back to the slide. Okay. So this is about the power. So if you have question about this, please ask question. Please ask question. You are most welcome to ask question. Okay. If you don't ask question, I will move to the example. Okay. This example. Example: 400 watt of carrier is modulated to a depth of 75%. Calculate the total power PT in the modulated wave. So the first parameter is carrier. So this is PC. Modulated to a depth of 75%. What is this? This is actually referring to the modulation index. Okay. So this is actually related to double sideband carrier power, or AM. So the question should specify this is a AM. Calculate the total power in AM modulated wave. Okay. So since this is a double sideband full carrier example, so we can use this equation, P total equal to PC plus M square over 2. So 400 plus 0.75 square over 2. Remember, this is the absolute value. Don't put 75. Don't put the value 75, which is wrong. 75% is equal to 0.75. Be careful. So students also tend to do careless mistake by putting the value 75, which is wrong. So be careful. So the answer is 512.5 watt. Okay, straightforward. Okay, maybe we can do this example last. Oh, already have the answer. Okay. Okay, so an AM broadcast station's peak carrier voltage of 2 kilovolt. You see that peak carrier. So this is a VC. So VC is 2000 volt, has been amplitude modulated to an index of 75%. So this is actually referring to modulation index. So the carrier is amplitude modulated with another signal which has a frequency of 2 kilohertz test tone. So the carrier is modulated with test tone. So this test tone is actually the input. So 2 kilohertz is actually referring to the message frequency. The station broadcast frequency is 810 kilohertz. Compute the following. So what is broadcast frequency? Broadcast frequency is the radio frequency that you transmit into the medium, which is referring to the carrier frequency. Okay, the broadcast frequency is the radio frequency which is used for transmission. So it is the carrier frequency. Remember, broadcast frequency is the carrier frequency. And if we want to listen to this radio station, we need to tune our radio to the carrier frequency. Remember, when you want to listen to radio, for example, you want to listen to Surya FM, which is 88.5 megahertz. So you need to tune your radio into that frequency. Okay, for example, I want to listen to this radio station. I'm driving a car. I want to listen to this radio station. So I need to tune my radio to 810 kilohertz. So that the frequency that I tune is actually referring to the broadcast frequency, which is the carrier frequency. So actually I'm tuning to the carrier frequency. Okay, so kita sebenarnya tune kepada frekuensi carrier. Okay, apabila kita tune radio, sebenarnya kita tune kepada frekuensi carrier. Okay, so compute the following: the lower and upper sideband frequencies F, LSB and F USB. Okay, so we F LSB if FC minus FC minus FM, F USB is FC plus FM. Okay, so 810K plus 2K for upper, 810K minus 2K, you get the lower sideband, which is this one. Okay, so 810 minus 2, you get 808 kilo. For upper sideband, 810 plus 2, so you get 812 kilohertz. So this is straightforward calculation. Find the peak modulation voltage, Vm. So Vm is actually equal to MVC, because we already know the M, we already know the VC. So we can calculate the Vm. So 0.75 multiplied with 2000 volt. Okay, 0.75 multiplied with 2000 volts, so you get 1.5 kilovolt. Okay, 1.5 kilovolt. And then what? Find find the peak lower and upper sideband voltage. So VLSB and VUSB is equal to Vm over 2. Or you can write MVC over 2. Okay. So remember, this is using double sideband full carrier. So how do I know that this is a double sideband full carrier? Because this is a AM. Remember, AM is a general term for the double sideband full carrier. AM is the general term for double sideband full carrier. And in your notes, every time it mentioned about AM, it is referring to the double sideband full carrier. Unless it is specifically mentioned other type of AM, which you will see later. Okay. So we get how much? So 1.5 kilo divide with 2. So 1.5 kilo divide with 2. So you get 0.75 kilovolt. Okay, just divide with 2. So 1.5. So you get 0.75 kilo. Okay, kilovolt. So this is similar with upper sideband. So both sideband has the same amplitude. Okay. And then what? The last question. Maximum signal amplitude. So Vmax is equal to Vc plus Vm. So both in terms of peak amplitude. So that means this is 2000 volt plus Vm here is 15. Sorry, maybe this is, I can use a K. 2 kilovolt, 2 kilovolt plus 1.5 kilovolt. So this is equal to 3.5 kilovolt. 3500 volt. Okay, 3500 volt. Finish. Okay. Okay, so that's all for today. Okay, that's all for today. So this is 4:44. So I finished 15 minutes earlier. Okay, because the next example 3.4 is a lot, so it needs need some time to complete. Okay, so it needs time to complete. So maybe next week I will start with example 3.4. Okay, so your test is actually until here. Your test is actually until this slide, example 3.5. So next week I will explain about example 3.4, and then we move to example 3.5 and proceed until the rest. So next week I will proceed until modulator circuit. Okay. So finish. So that's all for today. Commercial 45. Okay, so you can open your QR code to scan the attendance. Okay, boleh open QR code. So I will show the QR code so you can scan your attendance. So after scan, you can go out. You can go to Bazaar Ramadan and see you again next week. Okay.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome.
Thank you,
Doctor.
Doctor.
Welcome.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Okay, welcome.
Thank you,
Thank you,
Doctor.
Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Welcome.
Sorry doktor,
Ya.
saya tak boleh scan doktor.
Nama siapa ya?
Muhammad Hamsyari.
Muhammad Hamsyari.
Me too, Doctor.
Muhammad Hamsyari Hamizan
Ya, saya.
Doktor, saya
Okey.
pun tak boleh scan tu.
Siapa nama?
Thank you doktor.
Dia Akmal.
Sorry, pada
Sorry,
siapa nama?
Doctor.
What's your name?
My name is Shunda.
Sorry, repeat again one by one. Who's?
Doctor, I need to take my name because I can't do QR
So
code.
what's the name?
Sundus.
Okay, Sundus. Okay, I already take
And
it.
also Osama, Doctor.
Osama.
Yeah,
Okay,
thanks.
Osama. Okay. Who else?
Thanks a lot, Doctor.
Okay, welcome. Who else?
My name, Doktor.
Who?
Dia Akmal.
Dia Akmal. Okay
Ya.
dah. Okay dah. Who
Terima kasih,
else?
Doktor.
Who else?
Thank you, Doctor.
Amri, Doctor.
Okay, siapa tadi?
Amirul Amri, nombor
Amrul Amri. Okay, nombor 15. Okay, done.
Thank you, Doctor.
Ayo, Doktor. Goodbye.
Where's Muhammad Abdul Karim? Muhammad Abdul Karim, are you there? So that's all, okay? So Muhammad Abdul Karim absent today. Okay. So I will stop sharing. Hey, Muhammad Abdul Karim, you are there? Hello? So you attend the class actually. So I will include your attendance. Okay. So that's all, Muhammad Abdul Karim. I already take your attendance.